Okay, so today we're going to talk about a new FPGA board. We're going to talk about the Fireant. The Fireant, as you can see, is a FPGA that I got from Crowdsupply. It's very tiny, and they had a very successful sourcing there. You can see they raised $6,000 out of their $5,000 goal. Now it was a little bit delayed because this is actually made in Hong Kong, and if you follow the news, you know what's going on there. They're having some issues, some rioting, etc., and that did delay it a little bit. But I got it the other week, as you can see, it's rather small. Let me bring up the actual physical. If you can see it back here, it's running, and you can see it compared to the Arty. So it's tiny. It's probably about the size of one, like a Adafruit Trinket or one of the smaller Adafruit dev boards. So it's tiny, but it isn't at full FPGA. Not as powerful as the Arty or as the Zybo that we've been looking at, but you can still do quite a lot with it. So what I'm going to do today is I am going to first show you a few little things. They do provide instructions when you get it on how to set things up. You do need to download if you order it, they will give you information to set up an account on the Efinix, if I pronounce that correctly, website, which is the maker of the FPGA, and that'll allow you to download their software and what you need. So basically what you do is you download the software, you unzip it to a directory, and there are two things you have to do. Let me bring up so this is how you start the Affinity software. I'll get to that in a second. But basically, what you have to do that is install, if you're running on Linux, you would install the drivers like this. And if you are running on Windows, they have other separate instructions for Windows. So what you're going to do is, once you have the drive install the desktop. It's also running the shell file. Now this is interesting. I tried using the icon that they installed, and that didn't quite work very well. It was missing some stuff. It would not bring up the programming window properly. So what I found in their instructions, if you have to run, let me make sure this is up on your screen. I can show it to you. Okay, here we go. So what you have to do, as I said, you're gonna have to install the USB driver. It's never gonna find it, your device. When you start it up, you run this setup. This is going to set the environment properly, so when you then run Affinity, it'll properly bring up the software, and it'll bring things up correctly. So here is the Affinity software. And what we're going to do is, this is how it comes up. We're going to create a project, and I'm going to go through, they have instructions here. So I'm going to go through that. And okay, I'm going to go through the instructions. So the first thing you got to do is you're going to create the project. So I'm going to create the project, and I'm going to call it Counter. I'm basically recreating a project. They do include two projects that you can download from the company that makes the Fireant. And let's see what we got. No, we got the, make sure I have the right board. Okay. Yep. And the Triton, this is the device. Click on OK. And it'll create the project for you. The next thing you want to do is create your design file. So that's, it's basically your Veralog file. That's the example they gave you. And let's see, I want to, nope, add, nope, that's adding an existing file. I want to create file name is counter, and we can, now interestingly enough, you can also use an external editor on here. You can set it up to, if you use Atom, if you use Microsoft, Visual Code, and it's, so now what I'm going to do is I'm going to, let me show you here, if I can bring that up. So they have the code they provide in the example. So let's copy and paste that. And this is just a simple counter. Let me save on here. Here we go. So save that. This is our code. Now the next thing they tell you to do is there is an XML file that defines the peripherals for this device, and this is called counter peri for peripheral.xml. So look, what we're going to do is we're going to bring it into the project file. So let's do that. Copy. And then we're gonna, now I did save the original one just in case, and we copied it in there. And the next step, once you copy it in there, is you're gonna open the interface designer. So let's see, tools, open interface designer, and you can see it's showing you the, and that looks, let's see what we got. I'm comparing it to what is coming out, and that looks correct. So now we have to generate the constraint files, and the way you do that is in this there is a little button here, and this little button will generate your constraint files. So make sure that you're seeing this. Yep. Oh, it's a separate window. Well, there is a, you'll see in the instructions. Let me see if I can bring it up real quick. Okay, now you can see this, and it was this little green button here that generates the constraint file. And then what you're going to do is you're going to generate a report. And did I miss a step here? No, check the design. So we can check the design here. There's no issues. We generated the constraint file here. And now what we're going to do, so the constraint file is similar to what we saw with the Zybo. It basically tells the software what this thing has, essentially, what GPIOs. And if you notice, looking at the board, it has a lot of GPIOs similar to, and actually I should bring that up before we're done today. So now we generate a report, and that is here. And so I don't know where you would see the report. Generate report. So you generate the report, and so we have our report, and the next thing we're going to do is exit, and we should have, well, so now let's see what happens. I'm going to try to build it, and there's an order. It's very nicely laid out here. Let me go back to this screen because now you're not seeing anything. It's very nicely laid out the way they do this. First thing is your synthesis. Let's make this bigger. And it's running that. And then placement and routing. And then this is so you're going through and you're generating the bit stream. And now what we should be able to do is open the programmer, and yes, it came up, and we got, it knows what device. It's gonna basically rewrite. You have two ways, JTAG and SPI. SPI is gonna put the new close. I think here's our hex file. So that's the image. And what you're gonna, let me make sure, because I don't think this is up. And okay. So you can now see that. And what I'm gonna do is, let's see, is start the programming. As you can see, it's erasing the flash, and then it's writing the new flash, and it's successful. So we close that, and we're going to close that. Before we do, let me go back and let's see if this is going to work. You can see it's just got that one light now. And let's see what happens when I reset this. And as you can see now, it is showing the, let's get that. As you can see, it's doing the counter. And by pressing these buttons, I believe what this does is speed it up or slow it down. They're kind of tiny. You see how fast that's going now? So that's what this sample program does. And it's a good example because it's a little bit more sophisticated than Blinky. And let's have a little bit of a look at this. Let me get back to it. No, there we go. So what we are doing is, let me make sure that I am. All right, here we are. So you can see, this is Veralog, and before we were looking at VHDL, but this is Veralog code. A little bit different syntax, it does the same thing. So what it's saying is, when you have, it looks like you have two different clocks here. You have, let's see, input is, on this, you got the LEDs, the buttons, the reset, and the clock. So you're assigning these clocks to different values that came in, which is essentially taking you're essentially hooking up the input to the, it's like hooking up a wire, basically. So on the positive edge, that means when if you think of a wave, a clock signal, it's on the positive edge when it's going up. If it's locked, then go through the counter, and you're shifting, and you saw that. Now, this is where I believe it's doing, it has the input clock, and then it has an internal clock, for lack of a better word, that will speed it up as you hit the button. So that's essentially what this does. So button 1, you've got two, button 0 and button 1, and in one case it speeds it up, in one case it slows it down. And that's what this program does. So that is essentially an introduction. Let's have a look at something else, and I don't know if I need to bring it up. I want to show you. They have it in here because it's kind of, here we go. Let me make sure that's up, because right now you're looking at the code. There we go. Okay, so you can see this looks very much like any of those dev boards. You have your ground, your power on both sides, and you have a bunch of GPIO items that you can hook up. And one of the things I had to do on there was solder on the headers so that we can stick it in a breadboard and actually connect to things. So let's see if there's anything. No, I think we pretty much covered the main points, and you can see how you can do a simple project in this software and using this hardware. And what's nice about it for a beginner is it's inexpensive. It has all the capacity of where you can do your basic learn how to program in digital with digital design. So, and the other thing it handles, I know, whoop, I was hitting the wrong thing here. The other thing, I'm trying to see where the reset is at. There is a reset, and I think that's yeah, it's just, I believe this might be the reset, because one thing that you can do on this is always reset to the beginning. And if we go back to let's go back to this. If we go back to here, yeah, so it has the Triton 3.3. So that's important to remember, so that when you're working, trying to attach things to it, you know what the limits are. And let's see, into 6 LEDs, including 2 flash. Wonder where it's talking about the buttons. Well, this is a reset button, and let me show that to you. If I hit that, you see how it starts? Oh, I didn't show it to you because, oh yeah, you would have seen it. Good. So that's it. Not sure. I think it would be good to do a little bit more on this to go over some, basics of working with this. This is really good for students and people who want to get started and don't want to spend a lot of money. Because as you know, the Digilent boards, the Arty and the Zybo are not cheap. This is relatively inexpensive. Not fancy software, I mean, but that also means it's not bloatware. It's not this massive thing that could be a bit overwhelming. So yeah, I think we're going to do a little bit more with this. Anyway, thank you, and I will speak to you next time.